Good morning all. Welcome for this lecture. Today we are going to discuss the types of DC motors. Okay. So we'll see how on what basis the DC motors are classified. Okay. This is all based on the types of a field winding is connected, how it is connected to a armature. Okay. There are again in DC motors there are three main parts, means three main types. First one is a DC shunt motor and a DC series motor and DC compound motor. Okay, again in a DC compound motor we have a long shunt and a short shunt. Okay, let's see, it is same as that of your generator, also classified. Okay, classification. And then now let's see the first one, DC shunt motor. In this type the shunt field winding, okay, or field, and this field winding, okay, this field winding is connected across the armature. Okay, so and remember this shunt winding or field winding is connected in parallel with this armature, so it is mentioned, let's take it as a RSH. Okay, shunt field resistance. Okay, and these two field windings, means field winding and armature both are in parallel, and along with the means these two combination is supplied by the supplied voltage V. So therefore all three are in parallel, so V will be equal to voltage across this and voltage across this. So V should be equal to ISH into RSH. Okay, will be equal to voltage across this. So let's see how, what are the parameters of a current and voltage has to be calculated. So total current drawn from the supply is denoted as, you know, IL. Okay, this current will be equal to, at this point if you apply KCL, okay, if you apply KCL you get this formula, right? IL is entering and IA and ISH are leaving the point and leaving that node. So therefore IL will be equal to IA plus ISH. Okay, and next what we have said is, so this voltage across this and voltage across this, all three are in parallel, so voltages remains the same. Okay, let's take here you can write V is equal to in terms of this, or V is equal to in terms of this. Let's write V is equal to first in terms of this one. Okay, so when you are writing that, okay, so when you are writing that, V equal to what voltage across this is nothing but, as we said, in the armature we have a back EMF in the motor. We have discussed about this in earlier, means a previous class, EB, as well as the armature has the internal resistance RA. Okay, voltage drop across that also occurs. Therefore V will be equal to EB plus IA RA. Okay, EB plus IA RA. Therefore, so first equation is this, V is equal to EB plus I into RA. Another equation with respect to this one, V should be equal to this voltage across this. You know current flowing through this winding and you know the resistance of that winding. So therefore what we have to write is V is equal to ISH into RSH, right? So therefore ISH can be calculated as V divided by RSH. Okay, and in this current, whatever flux produces is directly proportional to the shunt field current. Okay, so remember, and as we have seen this connection, all three means supplied voltage is in parallel with these two combination in parallel, so voltage remains constant. Okay, that you can say as long as the supply voltage is a constant, which is generally so in practice, the flux produced is also constant. Hence this DC shunt motor is also called as shunt, means a constant flux motor. Okay, we'll move to our next one, that is DC motor. Okay, sorry, a DC series motor. Here the field winding, here we have taken that field winding as RSE. Okay, field winding is connected in series with the armature, therefore it is called as DC series motor. So since it is connected in series, we have taken it as RSE, named it as series field winding. Okay, so now we'll we'll see the current and voltage formula. As we know, this is the IL. When we have given a supply voltage, then current starts flowing, that current is IL. Observe this part are in series, so in series current remains same. Therefore IL will be equal to current flowing through this resistance as well as the armature, so IL will be equal to ISC and IA. This you can write. So then what about the voltage? Voltage is nothing but voltage drop across this plus voltage drop across this. Okay, then that voltage drop across this one is what? EB plus IRA, and voltage drop across this is IAC into RAC. Therefore, just in place of IAC, you just substitute IA, just for the simplification, because these three currents are equal. So what we can write is V equal to EB plus IA. If you take outside from these two, then there will be RA plus RAC. Okay, so this you can write. And remember all these formulas and all this. If you remember this circuit diagram, easily you can write all these things. Okay, only thing is you have to remember this circuit diagrams of each types. Okay, and then in this series motor, entire armature current is passing through the series field winding. So the flux produced is proportional to the armature current, or you can say it is series field winding. Okay, since these two are in series, current means same. Okay, so this is for the series motor. And next we will discuss about the DC compound motor. As we knew, the compound means a combination of this series field winding, whether it is connected in series or whether it is connected in parallel. Okay, not or. So part of this series is connected, means field winding. A part of the series field winding is connected in series, and a part of field winding is connected in parallel. So therefore, so this combination can be taken. So let's see how much part of the field winding is connected in series and how much part of the field winding is connected in parallel. So based on this, we have this short shunt compound motor and a long shunt compound motor. Let's see what is a long shunt compound motor. Remember this by name itself, long shunt compound motor. Okay, meaning of this one is a length is more of a shunt. Okay, means parallel connection, field winding is connected in parallel will be means much more longer than your series. Okay, so that you can observe. In this, what happens is your field winding is connected, shunt field winding is connected to the a combination of in parallel to the combination of series field winding and armature in series. Series field winding is connected in series with armature. This combination, for this combination, your shunt field winding is connected in parallel. Okay, you can observe your shunt field winding is connected in parallel with a combination of series field winding and armature in series. Okay, so from this we can write the equations for IL and all. Total current from the supply is given as IL will be equal to, again you can apply KCL at this point, then IL will be equal to ISC plus ISH. Okay, here you can say, so these two IAC will be equal to IA. Okay, these two are in series. So this equation we can write. Therefore, what you can write is this: in the place of IAC, you can replace your IA. That's it in this same equation, right? So then what we can do is, we can be given in two various, means in two terms. So we can be given in terms of this, and we can be given in terms of this. Both are in parallel, so voltage remains the same, this V and this V. So let's write both the equations. So let's first write with respect to this one. Okay, V is equal to, what about this? So V is equal to voltage across this, that is ISH into RSH, ISH into RSH. So from this, ISH can be written as V divided by RSH. Okay, this is one term. Okay, another one is V can be expressed as in this terms also. Okay, let's see how we can write this. V will be equal to what? So voltage across this plus voltage across this. As you know, voltage across this is IAC into RAC. Okay, and voltage across this is EB plus IARA. Right? So combination of this. So therefore, V is equal to EB plus IARA plus IAC into RAC. So here just in place of IAC, we are placing as IA. That's it. You can observe this equation. Okay. So this is about your long shunt DC compound motor. Okay, let's see the short shunt compound motor. Meaning of this one is, a shunt field winding is connected only across the motor, means armature. Okay, so this combination is in series with a series field winding. So this is a short shunt. You can observe this name. Short shunt means short in length. So this shunt field winding is connected only to the armature. Okay, from this diagram, circuit diagram, we'll calculate what is the IL and all. Okay, let's see. Total current is IL. IL is what? Is nothing but your ISC. Both are in series, right? So this equation you can write. Next is ISC will be equal to, now you have to apply KCL at this point. Okay, apply KCL at this point. ISC is entering and IA is leaving and ISH is also leaving. So therefore ISC will be equal to IA plus ISH. Okay, so ISH is nothing but your IL can be replaced. So it is equal to IA plus ISH. Okay, let's see the voltage drops across each field winding and your armature. Observe here, V has to be given in terms of this, because this and this combination are in parallel, a series. Okay, so therefore V should be equal to this plus this. Okay, these two are in parallel, so you have to consider any one among this. Okay, I repeat once. So V should be equal to this plus this. Okay, or you can take V equal to this plus this. Among these two, you can consider any one. I'll consider only this one. Okay, first we'll decide what is the voltage across this one. So voltage across this field winding is ISH into RSH, right? Okay, and then what about this voltage drop across armature? It is nothing but EB plus IARA. Sure, you have to remember this equation. These two are in parallel, so voltage will be equal, right? So I'll write here and you note down this. ISH RSH is the shunt field voltage across shunt field winding will be equal to EB plus IARA. You write it aside. Okay, this is equal. Whenever EB plus IARA comes, you can replace this with the ISH RSH, or wherever ISH into RSH comes, you can put this EB plus IARA. Okay, yes. Once you got this voltage across this and this, both are same. I'm going to consider only one. So this I'm going to consider. Then what about V? V will be equal to voltage across this plus voltage across this. Okay, so then V is equal to voltage across this is what? EB plus IARA. EB plus IARA plus ISC into RSC. Okay, so then what we can say is, so just here in this equation, what we have done is, this in place of ISC we have placed IL, since these two are equal. Okay, so just we have written, and I told you to copy this equation. We are going to use that. Okay, so observe voltage across this if you'd like to calculate. Okay, as we know these two voltages are same. Let's calculate voltage across this is what? This is what we know, this equation, right? V is equal to EB plus IL RSC plus I into RA. In this, voltage across this is nothing but your EB IRA. Okay, so from this equation, can you write what is EB plus IRA equal to? RA equal to is what? Means is nothing but here we send this one this side minus IL REC, sorry, REC, right? So then EBIARA is nothing but V minus IL into REC. Okay, so what we can do is, so voltage across shunt field winding ISH into RSH, what we have said, is nothing but your EB plus IRA, right? Okay, and then this can be written as V minus IL RAC from that previous equation. Okay, so then from this equation as well, we can write ISH. ISH can be written as V minus IL RAC divided by RSH, or ISH will be equal to EB plus IARA divided by RSH. Any one formula you can use. Okay, so as we have studied the DC compound motors, you have a long shunt and a short shunt. In that long shunt compound motor, you can have a cumulative or differential type of type. Okay, in generator we have studied what is the cumulative and what is the differential. So field winding, those two fluxes are in a same direction or in opposite direction. Okay, based on that we are going to decide cumulative and differential type. So even in a long shunt also we have, even you can have in short shunt compound motor also we can have a cumulative and differential type of motors. Okay, I hope it is clear with you about the types of DC motors. I repeat once, you should know the circuit diagrams, okay, and the basic concept of current and voltages. Then all the formulas you need not remember, because anyhow you are going to means you can write by yourself by seeing that circuit diagram. Okay, thank you.